Ladies and gentlemen, I'm glad to tell you today about ultrathin barrier layers that are formed with atomic layer deposition on packaging materials. Paper and board are typically used in packaging applications, and in order to get barrier properties, they are often laminated with synthetic polymer films or aluminium foil. This type of material combinations may cause problems in material sorting and energy recovery. In packaging, trend is to shift more towards more environmentally friendly materials, and in this concept, usually bio-based materials such as biopolymers are used. A challenge with biopolymers is their barrier properties and especially their sensitivity towards moisture. One possible solution for this problem is to apply thin aluminum oxide layers deposited with atomic layer deposition to enhance these barrier properties. Atomic layer deposition is a technique that has been invented in Finland already 1970s, and traditionally it has been used in semiconductor and display industry. It can be used to form ultra-thin nanometer range coating layers, and it is based on sequential and self-limiting surface reactions, which means that it allows atomic layer control of the coating layer and also could beatability. The formed coating layers are pinhole free and conformal, and they follow the structure of the coatable substrate. This means that the substrate does not need to be planar, but also three-dimensional objects can be coated. Here is illustrated a principle of an ALD reaction. So the substrate is placed in a reaction chamber and precursor is pulled in the chamber. The precursor reacts with the active sites of the substrate and saturates the surface. After the precursor pulls, a purge section is followed, which removes all the extra chemical, and after that an oxidant pulse is introduced. The oxidant reacts then with the first precursor, and after the extra material is again purged out, the first atomic layer is formed. And this can be then repeated as many times as one did in order to reach the coating layer as thick as needed. The technique is performed under vacuum pressure, and typically the temperatures used are between 50 to 500 degrees. At VTT, we have several ALD reactions, and most of them are located in clean room environment. And this means that also the substrates to be used needs to be suitable for clean room. But we also have one patch reactor that is located in a semi-clean room, and this enables using more various types of materials such as polymer films, coated boards, papers, and so on. In this reactor, it is possible to use the various types of inorganic and organic precursors, and we have water and ozone as oxidants. And due to the fact that the temperature can be adjusted, it is possible to also deposit temperature-sensitive materials such as biopolymers. And we also have analytics at house so that we can analyze these formed barrier layers. So how could these atomic layer deposition be introduced to packaging materials? So as I said, these thin aluminium oxide coatings can be used to form barrier layers, and the idea is to form a totally recyclable material in which synthetic polymers have been replaced by biopolymers and the aluminium foil with thin aluminium oxide coating. And these materials could be used, for example, in dry food packaging, coffee or tea packaging, or spices, and also in blister packages. We have already demonstrated barrier-enhanced both water vapor barrier and oxygen barrier properties for various different types of biopolymers. I won't go through with this image in a lot of details, but in the image the red dots are the materials that have been coated with ALD, and the white ones are the substrate materials without ALD coating. And the lower the transmission rate is, the better barrier the property the material has. And we can see that here in the target area there are already quite many of these ALD-coated bio-based polymers. We have also conducted compostability testing for these materials, and here a PLA-coated board with and without a thin 25 nanometer thick aluminum oxide layer has been put in a compost, and it was observed that there was no impairing on the degradation for the material even with this aluminum oxide layer, and it was actually more the substrate material that dominates this degradation property. I wanted to show you this image just to tell that it's not all aluminum oxide that can be formed with this technique, but there are lots of different types of coating materials that can be formed with ALD. And with inorganic materials, it includes oxide, nitride, sulfates of many types. But besides inorganic, it's also possible to form organic materials or hybrid materials that combines both of these. And also, the thin film applications can be found in everyday or items that we use. And it's not only the barrier properties that can be poured to these products with thin films. For example, it is also possible to bring antimicrobial properties, for example, for filter applications or self-cleaning surfaces for windows or UV block or different types of functional properties. So, as a summary, the ongoing research we have conducted have indicated that ALD can provide interesting properties and possibilities for widening the application of fiber-based materials and bio-based biopolymers. Thin layers less than 50 nanometers can be used to improve the barrier properties, and they even with this aluminum oxide layer, it does not impair the degradation. This method enables use of biopolymers in even more demanding applications such as food and medical packaging. And now on, the ALD processes are mainly done in batch process, but there are lots of research done to going towards continuous and roll-to-roll process, which would in future enable producing these materials also in industrial scale. And there are also already some pilot scale machines available and in testing. Thank you for your attention.